So to solve this ALEKS problem, what we're going to be doing is finding a KF and then writing out reaction steps. So what's happening here is you're given an ion and you're also given, in my case it's ammonia, but you might be given cyanide or some other molecule. And what we're thinking about is the complex that the ion forms with both the H2O molecules and then how it basically gets replaced with these molecules. So I'm going to go ahead and start by writing out this equation here. This is kind of like the overall equation that shows all of the steps and gives us the final product that we want, which has the complex between this ion and the ammonia molecules. So we're starting out with water, and because I have 4 ammonia molecules, I'm going to have 4 water molecules here. And because water is neutral, my charge on this complex is still going to be 2+, which comes from the zinc 2+. Now we are going to be adding 4 ammonia molecules, so I'm going to do +4 NH3. And then what happens here is that these two get flip-flopped. So the NH3 becomes a part of the complex, and then the H2O is basically bumped out to the side. So once we have this equation, we can write a KF expression. And all we have to do here, the heavy lifting is done, we just have to put our products over our reactants. We can ignore this water that's in the products because it's not in the complex and we don't use water in these expressions. So I'm just going to take my zinc NH3 with my 2+ charge, pop that into the numerator, and then put these two guys into the denominator. Always remember that if you have a coefficient here like I do on the NH3, I'm going to raise it to that coefficient. Be careful here with your brackets. Follow this format because this works when you input it into ALEKS. You have this compound here, and then you have brackets around those, and then you're going to add your charge, and then you're going to add brackets around your charge. And it's the same thing in the denominator. However, if you just have it raised to a power, you don't need to put brackets around there. It should just be good as single brackets raised. But over here, since I do have the complex and I have the charge, I do have another pair of brackets around there. The second part of this problem just has us using this guy here. And let me go ahead and fix this. Should be zinc. So this is the exact same equation that we have up here, and we're just going to be breaking it down into the different steps. So in order to get from here to here, there has to be a series of steps where in each one, we're bumping out one of these water molecules, sending it over here, and moving in one of the NH3s into here. So eventually, we end up with all of these NH3s into this exact spot. And all of these waters are just going to be off on their own. So that means that with each sequential step, we're going to have 4 water molecules. Then we're going to have 3 when we take one out, then 2, then 1. So you can think about it, 1, 2, 3, 4. This is 5. This is the end point, but it wants the last step before we get here, and that's going to be step number 4. So I know it looks like a lot, but the only thing that is changing between each of these is that I'm moving an NH3 into the complex and removing one of the waters. So each time you're adding 1 NH3. You can see this entire column is the same exact thing. We're adding 1 NH3 at a time, and we're removing 1 H2O at a time. The good thing here is that we don't have to worry about any charge changes because water is neutral and NH3 is neutral. So it's just a game of moving things around until you finally get to the last step, where you have 3 NH3s, 1 H2O, and you're just one step away from finally getting here. When you input this into ALEKS, make sure that you do have your states. I don't have them down here because I wanted to make it as simple as possible, but up here you can see I have aqueous, 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 and liquid. Everything should have this aqueous state except for water, that will be a liquid. You don't have to worry about states up here because it's just your K expression, but down here make sure that you have them. Now, I would suggest, especially the first time around, kind of following this kind of format where you're bumping one in, moving one out, and then as you get to the second and third problem, you should get it down pretty pat. Now, there's one thing I quickly want to show you. Sometimes you might get stuck with a cyanide anion. The difference here is that this has a -1 charge, so we have to watch our charges because it's going to change our expression. So what happened here, here's my equation. This is H2O, the starting point where the complex is just the iron and the H2O. But then we're adding 6 cyanide anions. And what happens here is when I have 6 cyanide anions, well, that's a -1 charge times 6, which gives us a total charge of -6. And I only have one Fe cation, one iron cation, which has a charge of 2+. So I have 1 times 2, which is 2. So when I combine these two, I'm going to get -6 plus 2, which is -4. So our charge is going to be 4-. So hopefully you're given cyanide. If you're given another anion, just determine the charge and just balance them basically. Say, how many of these anions do I have? What's the charge of my cation? And then make sure that you have the right charge on this guy. And that's the only caveat with having an anion with a charge. So it was the same exact steps here to make the K expression. I have products, which is on the right-hand side of the arrow, over my reactants, which are on the left-hand side. And again, remember that you're raising the cyanide to the 6th power because we have 6 of them. Now, I think this is kind of a nice break here. They just ask for the first step, so you don't have to write out all of the steps like we did last time. You just have to write out the first one. So this is the kind of end that we get to, but the first step that we have to take is just by adding 1 cyanide anion. So we're still going to be starting with this Fe H2O 2+ complex because that's what we're starting with in the very beginning here. And then I'm going to add just 1 cyanide. And then this basically comes in here and bumps one of the waters out. So you're going to end up with FeCN H2O 5. So this means we have 5 H2Os. We have just 1 CN, and we have 1 Fe. Now notice here, I have Cn-, but here I just have Cn because now it's with the iron. So this is a 2+ cation, and this is a -1 anion. So we have 2 - 1, which is just 1. So we have a +1 charge here.